connections that are here.
Yes, but Felipe.
Felipe is not here.
Yes, he is here.
And the other?
Yes.
If you don't agree, you will start with the virtual. Okay.
Okay, but
So you mean virtual first, or the present first?
Or you still in the program, or you stay in the program.
Yes.
You stay in the program is better because someone have maybe imagine to come to see a presentation, and maybe as you have changed the program, he will not lose it. So you stick on the program.
Yeah.
Okay.
okay. So
It's already what time it is?
11 already.
11 already.
So
Let's
we
take
can
5 minutes. 5 minutes more. Maybe he will come also. Okay. Sorry, I have my phone. I can. It's out of. It's 11:02. Let's start at 11:05. Okay. So you have some minutes. Yes. Okay. That's okay. Fantastic. I would like also please remind me at the end of the session to take a pictures all together, okay? To have a memory of this session. And I would like, as I said, you will wait 2 or 3 minutes. Please, the presentators, if you want to say something about you, who are you, from which university, etc.
I am Lê Thu Hồng. I'm from Institute of Information Technology, Vietnam.
Vietnam, okay. Here in Hanoi?
Yeah, in Hanoi.
In Hanoi. In this university?
No.
No.
Yeah.
Okay. And you,
Yeah.
Miss?
I'm from South Korea.
South Korea?
Yes, I am faculty of Sejong University. Actually, the paper is written by students, but he couldn't come because he's working.
Okay, and you will come to present?
Yeah.
Okay, nice. From which city of South Korea?
Seoul.
Which?
Seoul.
Seoul.
Seoul. Okay. And which university?
The Sejong University.
Central University. Okay, from Seoul. Okay, nice. And the third guy or woman, the third one is woman or man?
A man, I
A
guess.
man? From which university, do you know?
Maybe University of Ho Chi Minh. Oh no, he
From Ho
from
Chi Minh.
he from US.
From US.
Yeah.
Okay.
I'm not sure if
Okay.
he's a student or he.
Okay. Nice. So what time is it? It's 11. Papa is 11, I think.
11:05.
11:05. I propose to start. Okay.
Yes.
Please, the floor is yours. Go ahead.
yes, just I share.
You are ready?
Yes, I share the presentation.
Okay. Fantastic.
Okay.
Okay. Thank you very much for the assistance. And please go ahead.
Yes. Hi everyone. I am Lê Thu Hồng from Institute of Information Technology, Vietnam. I would like to present my work on ICCSA 2024 tomato disease detection from tomato leaves in made using CNN-based feature attraction. Oh, sorry. I would like to present my work on ICCSA 2024 tomato disease detection from tomato leaves in made using CNN-based feature attraction, feature selection with well optimization, and SVM classifier. This work was done by Lê Thị Thu Hồng, Nguyễn Sinh Huy, and Đoàn Quang Tú from Institute of Information Technology, Hà Nội, Việt Nam. My presentation includes 4 sections. 1 is introduction, 2 propose method, 3 experiment and research, and 4 conclusion. Tomato plant is a common crop in many regions, and early detection of disease in tomato plant will benefit for farmers. Some common diseases often manifest on the leaf of tomato, such as early blight or late blight or leaf moth or spider mite or yellow cover virus. In the area distant in the distant areas, farmers frequently encounter challenge in seeking advice from experts. So, therefore, designing a computer-aided system for tomato creep detection is important. This system can aid farmers in identify disease to enhance overall efficiency of the crop and minimizing the losses. The image classification model can be used to detect disease by classifying the image into group of healthy and disease. In this work, we propose a hybrid model to classify the tomato leaf image for disease detection. Our main contribute include 1, implement a lightweight CNN model to extract feature from tomato leaves image. 2, performing a feature selection using well optimization algorithm. And 3, using SVM classifier for tomato leaf image classification. And 4, using public dataset for training and testing the model. The result on the test set indicate that the model achieve high accuracy with 98.46%. This figure is overview of our proposed method. First, the tomato leaf image are collected from database and resized and augmentation before pass through the base CNN for training. Next, the feature from image was obtained by features extractor. Then the feature was selected by the feature selection based on well optimized algorithm. And then we get a dominant feature vector with input to SVM classifier for final classification. In this study, we use tomato leaves image from plant village dataset. This is an open repository of plant leaf image with 14 types of plant. For developing the machine learning model to detect disease from plant. In this study, we only use the tomato leaf image belong to 10 classes. This is the number of the image across different classes. in the data sets. After collecting image, we resize them into 224 by 224 by 3 pixels to match the input of CNN. The technique we use for data augmentation include flipping, routing, or scaling, and cropping and padding. That is the basic method for image processing. In this study, we implement a simple CNN called the base CNN for feature extraction. The base CNN has 6 pair of mark pooling and convolution layers and a fully connected layer on the top. First, the base CNN was trained using tomato leaves image. Then the feature extractor was obtained by remove the last layer of the base CNN. This table is summary the CNN architecture. The input dimension is 224 by 224 by 3 pixels, and the convolution layer with the kernel of 3 by 3 and the depth of 32. After convolution and mark pooling, the feature map was flattened, then fed into a dense layer with softmax activation. In this work, we use the feature selection based on well optimization algorithm, and this algorithm include 3 phases. First is generating K-well, and the second is K-well engaged in a bubble network attack, and finally the well persuade random based on their position. We also use the SVM classifier for tomato leaves image classification, and we use a nonlinear SVM classifier for with RBF kernel. In experiment, we use dataset consist of 18,100 tomato leaves image belong to 10 classes from Plant Village dataset for training and testing the model. We train the base CNN from scratch using tomato leaves image, and the entire network was optimized by the Adam optimizer, and all algorithm was developed using Keras framework with TensorFlow backend and skitlearn library. To assessment the performance of model, we employ some well-known evaluate functions such as accuracy, recall, precision, and F1 score. This table shows the accuracy result achieved by the base CNN on the test set. we can see that on average across all classes, the base CNN achieve accuracy of 94.93%. This accuracy is acceptable. However, there is a significant disparity in accuracy in different classes. This moved us to continue improve the model accuracy and the balance between classes. And this table is so the accuracy result achieved by the proposed method. The average accuracy of the proposed model is quite high, reaching at 98.46%. And the accuracy among the class is consistently high, ranging from 97% to 100%. This table compare the accuracy between the proposed model and the base CNN. The proposed model improved about 3% compared to the base CNN. And furthermore, the accuracy across classes is more uniform compared to the base CNN. This figure is comparison of confused matrix of the base CNN and the proposed model. We can see that the correct prediction made by the proposed model is greater than that of the base CNN. In this study, we also perform a comparative evaluation of tomato disease detection methods. This table compares accuracy of different methods using plant village dataset. From this table, we can see that the accuracy of tomato disease detection in current study quite high. Some study is achieve approximately 100%. Our proposed model is quite high, and the number of parameters of our proposed method is smallest, and the storage plate is also minimal. This indicates that our model more compact with fewer resource, with fewer need of resource, and the execution time is faster. In summary, this work proposed a hybrid model for tomato disease detection using tomato leaf image that implements CNN feature selection and SVM classifier. The proposed model was trained and tested using public dataset and achieved a high accuracy of 98.46%. And the proposed model is lightweight with small parameter and memory requirement. The limitation of this study is that we tested the method on only one public data set. In the future, further testing will be conducted on different data sets, not only tomato leaves image, but also we maybe include other plant leaves. This is my presentation. Thanks for your listening.
Thank you very much for
Yeah.
your presentation. Is there any question from the audience? Someone? Yes? You have a question?
No, I will call authors. No question.
Okay. No question. Okay, you're the call, right?
Yeah.
I have a question. I don't understand something in your code. You took the plant, the lifts from the plant.
Yeah,
You go to the parcel with tomatoes, okay?
yeah.
And you took some leaves and you go to the laboratory and take pictures. How you do it? Or you take pictures in the parcel. How? How you took pictures? Because you analyze the pictures of the leaves. I understood well?
Yeah, in fact, we build an application, mobile application to take image from leaf of tomato, and then we use some processing on the image, and then we use the AI model to analyze the image, then predict the disease, the disease that the plant may be infected.
Okay. Okay. I don't understand very well, but we don't understand exactly how in practice it works. I mean, you have a parcel with tomatoes, okay?
I get the
You have
image.
an area with tomatoes, and you want to see if there is a disease in the tomatoes plants, no?
Yeah.
Okay. How you do this in practice? Let's say here is the tomato plants. Okay. What do you do? Here is the tomatoes. It's tomato 1, tomato 2, tomato 3, tomato 4. And you are right here. What do? You take a pictures of the leaf
Yeah.
with your mobile.
Yeah.
With your mobile, you take a picture of the plant.
Yeah.
Okay? But maybe you have 1,000 of tomatoes. Thousands. You take a picture, 1,000 pictures of one leaf of each plant. How you do it?
In the test phase, we take image of plant of leaf on the tree. Then we crop and focus on the one leaf.
One leaf of this tomatoes.
Yeah.
But you have many tomatoes.
Yeah.
How you control all the tomatoes? You have to go to each tomato plant, to each one.
No.
So do you understand maybe the question?
I guess.
How it
It
works?
is like you take the data set, that the public data set for the training, and for the test case, we take the leaf
Okay.
for each tomato.
From each tomato.
Yeah.
You have 1,000, you take a photo
Yeah.
of all.
Yeah.
But this is not very heavy work.
That's the work may be related to an agricultural lab and company. Yeah, they just take the picture every day to
Every day take or for the tomatoes.
just randomly to take the photo to see how the tomato development we base on those kind of the.
But if they have, let's say, 100,000 tomatoes, they took a photo of all the tomatoes. They took a photo.
It looks like that the garden is not really huge. I guess. Yeah.
But if you have a lot of tomatoes, I mean, to take a photo, and the other thing is,
So how
the other thing is that if you take only a photo, it's not enough, because you have taken the photo and related the photo with this plant. So you must know each photo of each leaf with which plant it's related.
it is affected to that leaf? Affected by the leaf?
You mean, I mean, if you have tomatoes here, okay, you have tomatoes,
Yeah.
red tomatoes.
Yeah.
I take a photo after another. How do you know which photos related with which tomato?
Yeah, that's why she mentioned about an application from the mobile. It's that application just for the data collection and pre-processing for the thing.
Okay.
Yeah, that's not manually. That's on the system. Yeah. Yeah. That's
Thank you very much. Very interesting. In Greece, you have many tomatoes, so this application could be very interesting.
But how many test case do you have? The test case for the data set.
The test case include more than 1,000 images.
7,000 images.
10,000.
1,000.
1,000 photos.
Yeah.
And how do you know which photos is related with which plant? How do you know?
I think that's irregular. They can just label the
1, 2, 3, 4.
something like this. Yeah.
Okay, thank you very much. Very interesting your presentation. We are out of schedule of 5 minutes. Okay, thank you very much. Please, the second presenter from South Korea. Thank you very much.
Thank you.
Be careful.
What is your presentation?
Actually, I can take this one. Yeah, this one. This one. Okay.
Okay, please, Malala, could you share the screen with the presentation? I cannot see the presentation of later, just the window. Okay, Felipe. Wait a minute. Okay. Okay. Felipe,
Yes, now I can see.
you can see now the presentation.
Yes, yes. Thank you
The
very much.
slide introduction, yes?
Of course. Okay. May I introduce myself right now or?
No. Do you see the slide introduction, right?
Okay, the introduction. Okay. Yes, yes.
Yes. Yes?
Yes.
Okay. So it's fine.
Okay, my name is Chechun No. I'm going to present about E-class, which has the capability of deciding proper I/O scheme for application characteristics based on. As you know that GPU technology has increasingly been developed to several areas such as deep learning, adapt technology of GPU.
Possibly do a little bigger.
Oh, okay.
The letters are already very small. Yeah, much better. Thank you very much.
Okay. I already introduced myself, so I'm going to skip these slides. Okay, so as technology of GPU has increasingly been developed to several areas such as deep learning adapt GPU to speed up computation. But in terms of I/O processing, the original way of using GPU is that there should be a data transfer between host storage and CPU memory, and then the data set should be brought into the GPU memory, which may cause a lot of I/O performance, override of I/O performance. So in order to solve this kind of problem, GPU Direct I/O has been developed to in the GPU Direct I/O, there is a direct I/O transfer between NVMe storage and GPU memory. So it can reduce the overhead of the original way of I/O processing. But the problem is that this is kind of direct I/O, which may bypass the benefit of page cache. So it is known that the small, especially small size of application data set will be good for page I/O. But if you are using GPU Direct I/O, the kind of benefit cannot be in the application I/O performance. So there should be a way of determining which one is the better for applications by considering application I/O parameters as well as you may have to consider the resource status of host server, which where the application runs. So in this paper, we are proposing a machine learning-based I/O classification scheme, which can determine which one is better for applications by considering I/O parameters as well as resource monitoring scheme. We call this mechanism as E-class. So our contributions can be divided into three aspects. The first one is that we can first determine which the better I/O schemes based on application execution parameters such as file size, file and I/O sizes and access pattern, and then current to the resource status of host servers, including CPU, GPU, and memory. Also, in order to improve the prediction accuracy, we are using machine learning algorithms. Currently, we are using only 3 machine learning algorithms, but if user wants to use the other machine learning algorithm, he can switch to the other algorithm without causing major modifications. Also, E-class, since E-class involves the direct I/O between NVMe storage and GPU memory. We are implementing some optimization for reducing this data movement. If machine learning based algorithm says that using direct I/O is good, then our the data set related to the application will be transferred to host storage to NVMe storage before running applications. Also, if we are, in this case, we are using some kind of prefetching schemes as well. But if the host server uses NVMe storage, we don't need to transfer the data sets for the applications. Also, we did some preliminary studies by using FIO benchmark. So as you can see that we are comparing GPU direct I/O, which is called GDS, because GPU direct I/O scheme. And then the original I/O is called the GPU in this paper. So as you can see that if the block size increases, the benefit of GDS is a little bit apparent, but with a small block size, such a benefit is not apparent. So if the block size is small, then we cannot say that GPU direct I/O always gives us better performance. So this case should be considered to determine the proper I/O scheme. Also, we have a lot of the stress test. This slide is only for GPU. So as we may expect, if the CPU stress test is put on the GPU server, then GDS does not have much influence on that, because GPU direct I/O does not involve CPU memory significantly. But in case of typical GPU I/O, putting CPU stress may cause significant tolerance, as you can say that. So we need to consider the resource monitoring scheme to proper I/O scheme as well. So this is the implementation details of our E-class scheme. So in our E-class scheme is composed of 4 classes. The first one is data collection process, which collects application I/O parameter as well as resource monitoring scheme. And the second one is classification process, which is to train data sets to organize models. This kind of models will be saved into E-class repository. Also, third one as fourth one is the reconstruction process and classified I/O process. Reconstruction process is kind of re-evaluating models, and then classified I/O process is related with to reduce I/O overhead between the storages. This is the more detailed of E-class structure. So the first one is collection process, which collects the necessary information to categorize the I/O scheme, such as file size, I/O access pattern, things like that. And the real-time stats of the host memory and CPU, GPU will be collected by using our own monitoring models. Actually, we used our monitoring models in this case, but since that is not the issue of this paper, we extract that one. We only focus on E-class. And then classification process extract I/O features to determine for categorizing the proper I/O scheme. Also, it has the steps for training I/O models, and then those I/O models will be stored into the repository. And the reconstruction process is update the existing models by packing more data sets from outside or running applications. As application run, after the application run, the as prediction as well as the data set produced from that application will be updated into the repository to re-evaluate that. Also, if the new organized I/O characteristics will be are recognized, then recollection process will re-update the models. Also classify the I/O process, mainly takes charge of moving NVMe device storage and host storage to utilize GPU direct I/O. And then this is an example of collection process. As I said, that there is a E-class configuration, and then this is very simplified version. Also, it has some I/O parameters, which includes file size, I/O access pattern, and then resource monitors scheme. Monitor information is here, and then the previously determined I/O prediction result will be used for the evaluate the models as well. And then this is the I/O categorization. Currently, we are using 3 machine learning algorithms, and then based on 3 algorithms, the accuracy of SVM is a little bit better than the others. But if user, as I said, if user wants to use different machine learning models, they can just specify either in E-class configuration or this model can automatically determine the better machine learning algorithm by comparing performance comparison ratio like this way. And then this is very simplified version of I/O reconstruction process. If the I/O parameter contributes to produce better performance, it will be included in our scheme, E-class scheme. But if it does not, it will be eliminated from our E-class. This is the steps for the simplified reconstruction process. Also, this kind of re-evaluative table will be updated in the E-class repository. Actually, we did some performance evaluations. Actually, this is the thesis of my student. Actually, he did a lot of performance. He has a lot of performance results, but this one is this presentation is only. I know that this presentation is only 15 minutes, so I let him extract many of the slides. I just want to show the FIO benchmark results. So in this case. This is the local performance, and that is Docker platform evaluations, and then most of that gives us the better performance with E-class, which combines with the GPU direct I/O inside it. Also, this one is the sequential read operation, the performance of a sequential read operation. And then this is the random read operation, but as you can see that even though the performance of E-class, which utilizes CPU direct I/O, gives better performance, but the performance difference may be significant. So user may consider to use CPU direct I/O when the application shows random access patterns if it does not want to use E-class. Also, this is the QSIM library, which is the library for the data evaluation. And then in this case, the performance between two I/O schemes does not match. So user can either use E-class or the original way of CPU I/O scheme. Also, we did some performance prediction accuracy between three algorithms. As I said, that SVM is much higher than the others, but user may use the other machine algorithms, and in that case, maybe the accuracy result may be different. So I'm going to conclude to that paper. So I present in class also for for determining the proper I/O based on application, execution, behavior, as well as resource monitoring scheme. Also, I showed some performance results by using FIO benchmark. But as a future work, we are going to use more benchmarks to prove its effectiveness. Actually, this is just a prototype, so we are still developing it by the other students. So in that case, we may have better result in the conference, and that's it.
Okay, thank you very much for your presentation. There is any question from the audience? No questions? Just a very small question, and we will pass to the next audience. Here, in your conclusion said that you will verify your schema with more benchmark. You said that in various ways to prove the fix. I mean, how many benchmark do you believe that is needed in order to say with certainty that is effective? I mean, how?
Yeah,
is,
actually, as you may know that benchmark is a very different type of benchmarks of
yes,
there.
how many types and how many long will take this?
Yeah, but usually the evaluating, they take a lot of months, like 2 or 3 months. And then right now we are using file banks, VD banks, IO zone, but those are related to IO operations. Actually, I want to see how effectively works, especially the machine learning benchmark like MLPerf, I guess, but I don't remember exactly the name of it. But those benchmark may generate a different way of access patterns, and then they have a different result. They may good.
Okay, I wish you success in your next benchmark. Thank you very much. I think you, as we don't have, he is not here. It's here.
Yeah.
Okay. Yeah. So please go ahead and put the presentation in the laptop. You are ready to go. You are ready to go for the presentation. You are ready to go home.
Yeah.
Where are you from?
Boy.
Huh?
Because this morning some program
Where are you from? Yes, no. Where are you from?
from here Vietnam.
Vietnam. Okay, you go back to where? Ho Chi Minh?
Yes, Ho Chi Minh City.
Ho Chi Minh City.
Yes.
Okay, please go ahead, give your presentation, and the floor is yours when the presentation is ready. Will be ready.
ICCSA. ICCSA. Yes.
But did you come to this conference 6 years ago when the conference was in Ho Chi Minh?
No.
6 years ago you were in Ho Chi Minh.
I attended this
First
conference
time.
the first time.
First time, yes. But you know that 6 years ago this conference was in Ho Chi Minh.
Oh, I
You don't know?
Yeah, I don't know.
Yes, 6 years ago you were in Ho Chi Minh. But maybe 6 years ago maybe you were too young.
I guess so.
Yes.
So this is
Second time in Vietnam.
second time in Vietnam.
Yes. First in South, now North.
Yeah, maybe I will attend this conference in the future.
In the future.
Yes.
Okay. Please, the floor is yours.
Yes. First, I should say thank you for giving me the chance to present my paper. The topic is optimizing for cloud workloads and a basis aware dynamic scheduling solutions. And this is the agenda of my presentation. First, I will introduce some background, what happened, and then why what motivates me to write this paper, and then some definitions of I use during the paper in the paper, and I give some problem formulations, and that is the evaluations of evaluation results of some experiment I conducted, and finally I conclude the paper with some future work. Okay, as you may know, with the rise of the computational applications, a lot of individual and companies get a lot of benefits, but with the limitations of processing power on the local device, that's hold back some further progress. So it's required a lot of humans and financial investment. Fortunately, with the appearance of the cloud computing, the cloud computing can solve these issues, but there is the other issue generated. That is the pay-as-you-go model of the cloud computing. So it's necessary to find a solution to minimize the completion times and cost for using cloud service. So and usually there are a lot of approaches try to minimize the completion times. I know if we have a projector remote control. Yes. So as I said, there should be some solution to try to find how to minimize the completion time and minimize the cost for using cloud service. And there are a lot of approaches try to solve this problem. But as you can see on this table, just some of them can fill in these issues. Like try to find the completion time and try to find the minimum cost. But the other issue generated. That's it. How to find the trade-off between the completion time and the cost minimum for using the cloud service. And you see that there are some other approach try to find the trade-off, but there are some other problem generated. That's it. What happens if the environment changes, like the dynamic environment? So some other approach try to solve this problem in the dynamic environment. But you can see that I don't see any approach try to solve this old problem, like completion times, minimize cost, get the trade-off between the completion time and the cost in the dynamic environment. So that's why I propose my solutions. I can solve this problem, and especially in the combinations or collaboration between clouds and force computing. So in my approach, I try to provide this is the necessary to find an approach with consideration of these criteria: completion time, network contentions, and cloud cost for using cloud service. That's why in these papers, I would like to try to solve, to propose approach that can consider the both factors, minimize cost and completion times, and get a trade-off in the fog and cloud computing environments. Especially this approach can work on the dynamic on the dynamic environments. And the center of this paper, or the heart of this solution, is a dynamic task scheduling solutions that can reduce the completion times within the cloud service, while consider the network contention and cloud cost for using the cloud service. And in order to go further, first we should know some definition I use in the paper. That's it, the task graph. Task graph is a directed acyclic graph, and it contains a set of vertices. Vertices can present for some subtasks or some subtasks. Subtask is like some application modules. One application, it can have many modules. So one subtask can be considered like one application modules. And the directed edge is present for the communications between the subtasks, like VI and VJ. And the view is it can be present for the computation time with workload. And C is present for the communication times with corresponding data transfer data. And here we have the finish time. Finish time of a task on a processor is equal to the start time of a task on that processor plus with the computation time of the task on that processor. And the other definition that is the processor graph. Processor graphs is topologies of network between vertices, which are the virtual machines or clouds or host device. This is, for example, a topology, processor graph. And in processor graphs, it contains a set of vertices. This is, these vertices, they are processor, or they are virtual machines. And of course, there is a communication links between these processors. And this processor is have different capacities, like have different RAM, CPUs, or hard disk. And it can have different processing rates and bandwidth, and different bandwidth to communicate between processors. And the next definition is the task scheduling. The task scheduling is how to assign a directed acyclic graph or task graph and processor graph in two systems, so that it can minimize the total commission time. Yeah, and this is how this is the model of my system. It's content switch layer. The first layer is cloud service. The other is fog layer, and the last layer is cloud customer. And the fourth layer, this one, in the 4 layers, there are many fog devices, right? And there is a device like fog brokers. It's like the heart of the system. The fog broker is receive a request from cloud customer, and then it's process the request, and it can like forward the request to the cloud or the proper fog device. And then when the fog broker is send the request to the cloud process the request, and it can, because the request is can be a bit, the data can be bit, so the system, the cloud, it can split the data into non-uniform chunk, and the chunk it can send back to this one, the fog, and then fog broker it combine the results and it send to the corresponding cloud customer. And with this system, I just how to formulate, how to do the mathematics formulations for the system. First, in each task or its module application modules, it can have different priorities, and the priorities can estimate this by the length of the critical path within a task. And yeah, suppose that we have the priorities of each task, and this one is the average computation time, and this is average communication times. And yeah, this one is start time of a task on processors. Start time of the task on processor is is equal to the is it like the ready time of the task on processor. Ready time of a task on processor is like a processor, it can ready to process the task. It finishes every previous task or previous subtask. And this one is early start time of a task. Like early start time of a task, like this one. The early start time of our task on a processor is equal to it's like every parent task finished, and then plus with the communication times of the parent task to transfer the parent task to this processor. And early finish times of a task on processors is equal to the workload of this task on this processor plus early start time of the task on that processor. And because my approach is not only consider the completion time of a task on processors, we also consider the cost for using cloud service. And this is the combination of the cost maybe happen when we use cloud service. This is the general cost is equal to processing cost plus the waiting cost and communication cost and the storage cost and memory cost of a task on processor. And let's consider one by one is this kind of cost. The computation cost is, we just follow this formula. It's like all loss divided by processing rate time with processing cost per time units. And the waiting cost is like waiting cost per time units time with, we just follow this formula. And TI is the finish time of a task, and this one is finish time of a task completed first out of the parallel task. This is the, for some tasks when in order to process a task on a processor, it requires its parent. The parent of the task should be finished, and this time the T minimum which means the finish time of the parent task, but the first parent finished. Communication cost. So this one is equal to the transfer cost per time units and time with this one. And this one is the data is transferred plus with the outgoing data from one processor to the other processor, this one, and divided by bandwidth. And this one is, I think, the most easiest kind of cost, that is storage cost. Storage cost is the cost, the cost when we store data on cloud service, and this is the memory cost. And when I have the how to get the early finish time of a task on processors, and I also had the know how to calculate the cost to processing a task on processors. I have the early finish time and I have the cost, and I apply this formula to compute to get the trade-off between the cost and early finish time. And this echelon, this one is like the cost conscious factor, represent a user preference for the completion time and monetary cost. So this number is like how much user prefer to use to consider cloud cost or completion time. This is the consider factor. And because as I said, my approach can work in the dynamic environments. So this is some criteria happen. Criteria requires for the dynamic environment. It says when there are several different tasks are running, if a new task needs to be started at any time, broker will check the available processor and allocates the most appropriate processor to the task to reduce in the shortest completion times. And this is some tasks of the task route are already scheduled. We may reschedule them during the arrival new task. This one. This one, the condition 2 and condition 3, they are very important for dynamic environment. And in order to evaluate my system, I conduct some simulations, and this is parameters used for the simulations. We have different different processor, different tasks, different processing rate, bandwidth, and cost per 10 units executed on a processors, and the cost of our data from processor and cost of waiting time. Yeah, we have different kind of costs and different heterogeneous environments. And we also consider our approach to compare our approach with other approach, that is contention-aware scheduling. This one is take account of the network contention, but this one, the greedy cost reduction algorithm, this one, is just consider the earliest finish time. So, the previous one is this one. We just consider two algorithms, and I'll just compare with two. The first is contention-aware task scheduling, and the other is greedy approach for cost reductions. And this one just take care of network contention, and the second one just consider the cost. That's it. So the purpose to compare with this, because you see our approach, it can consider the trade-off between the time and the cost. So that's why I compare our approach with this one, which just consider only network contentions, and this one just consider only the monetary cost for using cloud service. And as you can see on this figure, and this one, the context-aware task scheduling, this one. It can save a lot of times. Like this one is like the fastest one, but it has highest cost. This one. With this one, because the greedy approach for cost reductions, it had the least cost, but the highest time. In the meantime, our approach, that is dynamic cost time aware task scheduling. This one, my approach is like something in the middle. It can get the trade-off between time and cost. And you see, compare with the context-aware task scheduling, this one. Our method can save 19% cost for using cloud service, but it's 21% faster than the other one, that's the greedy approach for cost reductions.
Sorry, you have to go a little bit faster because you are 20 minutes already.
Oh, you didn't know. You didn't notice, so I didn't know. So sorry for that.
Sorry.
Okay.
You are in 20 minutes, so must go.
Okay, fast.
To conclude.
Yeah, and the other approach, the other evaluation is I conduct. Let's see how my approach work with the different number of processes, and in terms of scheduling or the completion time and the cloud cost for using cloud service. And it says it's easy to see that the cost, the time, when the number of processor increase, the time to process the task less, right? But the cost increase. Yes. No. Okay. I can conclude my what happened? Okay. It's okay. I can conclude my
It's down. PowerPoint.
Yeah, I will see. It's okay, but I can say in my paper I propose a collaboration system that's the combined between cloud and core competence, and it's used to leverage the cloud competence, and also we will propose a task scheduling approach in the dynamic environments that consider network congestion and cloud costs, as well as we consider the trade-off between the cloud costs and completion times. And we also conduct some simulations, and you see that our approach can get the trade-off between time and cost compared with other approach. And in the future, we will enhance our approach to and conduct our approach in different environment to get a higher reliability and get some better performance. Yes. That's
Okay.
it.
Thank you very much. Is there a question?
Yes.
Please go ahead.
The first one, I think that I have many questions for you. The first one, I think that your problem in your paper maybe relate only to the cloud computing, not related to the fog. Because I think that a query can come from anywhere. So your problem only apply your algorithm in cloud computing. I think that is question one for you. And question two is that how you estimate the execute time before a query you apply to the cloud computing? How do you know?
Okay, yeah. Um, you know, when we send a request from cloud customer service, from cloud customer to cloud service, usually there may be the distance between cloud customer and cloud service, and because the distance, there should be something in the middle between clouds and cloud customer, because if the thing the one in the middle is like a mini data centers, and it can receive the request first, and it can process the request in case the request already solved, it send the request back to the cloud customer. So that's the needs of the collaboration between cloud and forks.
No, I can use a laptop or mobile, not fork.
So the fork is the laptop or mobile is in my approach we can consider it's like some cloud customer service. It's like the third layer. The second layer is fork. The fork is like mini data center. It's like router. Yes. So it's bigger than laptop or mobile device.
Okay, maybe we can continue during the lunch or the schedule. Where is the technical assistant? Because you can continue with the third, I think it's from virtual. But until you can do it?
Probably yes.
Okay.
Yes.
Okay, thank you very much.
Yeah, thank you.
Thank you.
Thank you for occupying a lot of time.
Okay.
Actually, my paper is much bigger than this, but
Yes, but the presentation is only 15 minutes. And,
Hello, it's me right now, correct?
Yes, it's your
Okay.
turn. You can share
Okay.
your screen.
Okay.
Okay.
Can you please tell me if you're seeing my screen correct?
Yeah.
Okay. Are you listening to me very well?
Yes, we can listen you very well.
Okay, perfect. Shall I begin?
Yes, please.
Okay. So, hello everyone. My name is Felipe, and I'm going to present to you this paper that is entitled "A Real-Time Visualization Tool of Hardware Resources for Flutter Applications." I am one of the two authors. The other is Claudio Shepke. That's my professor at the Federal University of Pampa in Brazil. Okay, just a quick summary. I'm going to talk about the introduction, present the main reasons of the study, some related work, our methodology, some experimental results, and the conclusion and futures work. So, but first, I'm going to present you the tool, what we developed. So this is just quick demo. This is Wondrous. It's an app that you can download in Play Store. And this here, this overlay is our tool. So what the tool does, the tool shows how the app is performing. So here we have a lot of animation. So we can see that the frame drops like in the 30s or 40s FPS. And when and we can see in this side the network income and outcome package. So here we can see that the frame rate goes up because it's a very simple part of the app. But when we see a lot of animations, like in this section, the frame drops very fast. So let's continue. I'm just going to introduction. So first of all, why we need to focus on performance? Because there are a lot of restriction hardware when we're talking about mobile development. Mobile, it's a very different kind of field because when we start to developing for mobile, we have to think that if there are a lot of people in the world that does not have a very powerful mobile cell phone. So we need to start thinking that our application must work in this scenario, in these devices. So another key point that we need to think is source resource consumption. So no one likes when you open an app and it starts draining your battery fast. So or you probably will not use it anymore. Um, Another point that we think of is more apps because every day there are a lot of apps that are being created. So with this approach, we need to think of performance and start to analyze our app's performance. So another point is the increasing number of devices in the world. So in this chart, we can see that in 2022, we had 7.88 billions of devices connected worldwide, and this number just increases. Um of course, the main part of this assumption is short range IoT devices, but you can see that these here are the mobile phones, and they are not small, so it's a very big number. Compared it to PC, laptop, or tablets, it's a very, very big number of devices. Uh, so uh, what ways we have to develop software to mobile devices. We have, when we think about Android, we can develop using Java or Kotlin, or to iOS, we can use Objective-C or Swift. But in this approach, we have to develop to platform specific. So if you want to develop to Android, you have to code to Android. But there are some other approaches like Flutter, React Native, Ionic, and Xamarin that we can create to multi-platform at once. So in this paper, in this presentation, I'm going to discuss about Flutter. Okay, Flutter is a UI toolkit that's used to develop multi-platform apps. It uses Dart language as to develop the applications. Flutter was created by Google and it's maintained by Google. And the version 1.0 was released in 2018, so it's a very new uh, so with Flutter, we can create apps to Android, iOS, web, Linux, macOS, and Windows all at once with just one code base. Okay, what were the goals of this work? So the first of all, the tool, we wanted to create a tool that help the developers to um, increase the performance of the app. So some points that we thought were necessary, that the tool was easy to use, less invasive as possible, because as you can see, and I will show again, it's an overlay that stays on top of the apps the developer is creating, so it should be invasive. And it must indicate FPS, network, and RAM usage. So another goal that we wanted was to extend the Flutter's bibliography because it was very poor, like in the academic way, because Flutter's documentation is good, but in academics it's not so well documented. So another thing is an open source repository that we already created and published the tool in the pub.dev, that is the main repository to Flutter and Dart packets. So what is an alternative? An alternative to our tool is DevTools. That's a lot of it's a set of tools that already come with Flutter, but here I created a new Flutter app with the full integration, and I'm now running the Flutter app, so it can give me an URL so I can open the browse and see the DevTools UI. Um, DevTools is a very powerful tool, but it's very complex because sometimes you do not want to get all the information that DevTools give to you, because sometimes you just want to see how your frame time is going, but DevTools can give it to you, but even more. So you can see that there is a lot of tabs and buttons, so you can like really see what's going on with your app. But sometimes it's very complex and not so easy to use for beginners. So let's continue. Some related work. I'm going to present you some package that already exists in PubDev. So the first of all are the performance package. It's a very good package, and it has this UI. So when you add it to your application, you can see these charts. It's a very clever and good package to use. And it's one of the main inspirations to this work. So another package is Lambert FPS Monitor. It shows it shows not so many informations as the last one, but it shows the FPS. StatsFL is like Lambert FPS, but without the charts. So we have show FPS that shows the FPS. It's very simple, and we have these two other package that performance FPS and memory info that does not provide the user a UI interface, but gave to the user some info through the code. Okay, just quickly our methodology. Some important aspects that we thought and searched that are important to analyze the performance are CPU, memory, battery, and network usage, as well as startup time, frame rate, user experience, latency, and crash rate. But to this work, we choose memory usage, network usage, and frame rate to work with. So frame rate. Here I'm just put the code that we used. So the frame rate we got through the schedule binding, that it's a kind of class we have in Dart code. So it allows us to get a list of timings callbacks that allows us to get frame timing. That's another class. And why it's important? Because with frame timing, we can get some information about each frame. We can use raster finish and vsync start um, to calculate how microseconds a frame got to be showed in the screen, like since it was the vsync starts until the raster finished. So now the memory usage, how we did it. So we could not use Flutter to get this information. So we need to go platform specific. So we went to Kotlin to develop this feature. So in Android, we needed to access Activity Manager. That's a class that allows us to get some information. And in this case, we access the memory info. With this method, we got access to total many and avail many that shows us respectively the total memory accessible by the kernel and the available memory on the system. So the network usage, how we did it. So also we need to go to Android specific. So we had to access traffic stats. That's a class that allows us to get two methods that are get total received bytes and get total uh, transferred bytes. So with two methods, we got all the traffic that are coming out and in our device. A downside of this approach is that it capture all data from all packets. So it's not just the info about our application, but it already gave us some idea how it's going on. So now the results. Um, what were our results? So frame rate. We got this UI, and it show uh, how the frame rate are going. So you can see each second how long the frames are being generated and how many frames per second we got. And the memory usage, we can see the total memory, the free memory, and the used memory in gigabytes. Um, the network usage, we can see how many uh, how many information we are uploading and downloading, and the charts adjusted themselves to the max value in the frame timing in the period of time that the chart is being generated. So some customization parameters that we have in the application. There are a lot of customizations you can do, like disable the whole overview or just some parts of it. Uh, I'm going to show you a second demo very fast to analyzing another app. This is Open. So now you can see that's not this app does not have so many animations. So we can see that the frame rate is better. It just drops when the books are being loaded. So after that, the application runs smoothly. So let's go to see some customization. As you can see, we can put the overlay what we want. So you can, in this case, here below. In this case, here, we can put whatever we want. We just need to configure it in our code in application. So some final considerations. Uh, so the future works that we want are DevTools extension that not so long ago, Google released a new version of Flutter that allows us to get more information and more data from DevTools. So it was good, should be good to investigate how many data we can get from these extensions. Another thing to do is measure the computational impact of our tool. So how much performance we lose when we activate our tool compared using it without the tool. And another point is increase tools use cases. So create more uh, measures, more aspects that should be considered to evaluate the application's performance. So here are some of our reference to this work, and thank you very much.
Thank you very much also for this presentation. I would like to ask the audience if there is a question from you or you.
What's the future goal of this one? Do you have any future direction?
What is the future goal for your project?
Okay. Well, the future work we're thinking of is, like I said, start to analyze the data we get from that tools, because it's a very powerful tool that Google already developed and keep maintaining it. But when the tool was first developed, it was last year, and this extension from DevTools was not released. So we had to work with we had. So now that Google launched these extensions, like we have more classes and more methods to work with, so we can explore and get more data. But it needs to be done by looking very well in the documentation, and like sometimes we have to try. Go and like try if the data that they say in the documentation is the right data that we want. That was a big problem that we had, that sometimes the documentation says something, and when we try to use it, it's not that well. So it's not where what they put in the documentation. So some future work, like the very close, is to analyze the DevTools extension and adopt it in the application.
Okay, thank you very much. Thank you very much for this presentation. Thank you all. Thank you the audience. And I will invite you to be ready for the continuation with the trip. Thank you very much, Felipe.
Thank you.
Bye.
Thank you.
Okay.
Can we take a picture together for memory? Yes. Let's have a picture.
Picture, yes.
Yeah,
We see this.
Is your first conference, right? Is your first conference?
Come.
Oh, okay. Sorry,
Come.
I don't like to take
You don't like? Okay.
Okay.
Okay, thank you very much. So,